We are here again in your subject, analytical chemistry, and in this session, we are going to discuss the qualitative analysis of some ions. Qualitative analysis deals with the process used to determine and identify the chemical properties of unknown substances. This could be from product development, or this could be from a suspicious substance present in a certain stock. It could be from a sample from a river, it could be a sample from a food, or anything that you want to determine the substance present in it. So in your laboratory analysis, the main activity that you should be doing there is to identify the cations and anions present in your given unknown. Uh, I will show to you how an illustration as to how to do qualitative analysis, or in could be illustrated in a manner that in a test tube you're going to add a substance or a chemical to test for its presence. So this is a sodium chloride solution, and we are going to test for the presence of the sodium. For example, it is unknown. So when sodium chloride is added to silver nitrate, a white precipitate is formed. So this confirms that this contains silver. This is also shown by some ordinary illustration in your daily life, in which jewelry is made up of silver. When exposed to perspiration, it gives a white precipitate, and then eventually, because of exposure to dirt, it will become black or green in color. Okay, here are some illustrations of your qualitative test for cation.
Qualitative analysis of cations. This video clip demonstrates how to identify common cations. To analyze what cation is present in a sample, we can carry out flame tests or add the appropriate reagents and observe the chemical changes. The following parts demonstrate the testing methods for common cations and expected observations. Aluminium ion. Aluminium ion is a colorless cation. Sodium hydroxide solution or aqueous ammonia solution can be used for the testing. Add sodium hydroxide solution to a solution containing aluminium ion. A white precipitate is formed. Add this aluminium hydroxide. If excess sodium hydroxide solution is added, the white precipitate will dissolve and a colorless solution will be obtained. If aqueous ammonia solution is added to a solution containing aluminium ion, a white precipitate will be formed. Add this aluminium hydroxide. If excess aqueous ammonia solution is added, the white precipitate will not dissolve. Calcium ion. Calcium ion is a colorless ion. It can be identified by flame test. In this test, a bright red flame is produced by calcium ion. Furthermore, if sodium sulfate solution is added to a solution containing calcium ion, a white precipitate will be formed. It is calcium sulfate, which is water insoluble. Copper 2 ion. Copper 2 ion is a blue ion. It can be identified by flame test. In this test, a blue-green flame is produced by copper 2 ion. Furthermore, if sodium hydroxide solution is added to a solution containing copper 2 ion, a blue gelatinous precipitate will be formed. It is copper 2 hydroxide. If aqueous ammonia solution is added to a solution containing copper 2 ion, a blue gelatinous precipitate will be formed. It is copper 2 hydroxide. However, if excess aqueous ammonia solution is added, the precipitate will dissolve. Tetraamine copper 2 ion is formed and the solution is turned into deep blue in color. Iron 2 ion. Iron 2 ion is a pale green ion. If sodium hydroxide solution is added to a solution containing iron 2 ion, a green gelatinous precipitate will be formed. It is iron 2 hydroxide. If excess alkaline solution is added, the precipitate will not dissolve. The same result will also be obtained if aqueous ammonia solution is added to a solution containing iron 2 ion. Iron-free ion. Iron-free ion is a pale yellow ion. If sodium hydroxide solution is added to a solution containing iron-free ion, a brownish-red gelatinous precipitate will be formed. It is iron-free hydroxide. If excess alkaline solution is added, the precipitate will not dissolve. The same result will also be obtained if aqueous ammonia solution is added to a solution containing iron-free ion. Zinc ion. Zinc ion is a colorless ion. If sodium hydroxide solution is added to a solution containing zinc ion, a white gelatinous precipitate will be formed. It is zinc hydroxide. If excess sodium hydroxide solution is added, the white precipitate will dissolve. Colorless and water-soluble zincate ion is formed. If aqueous ammonia solution is added to a solution containing zinc ion, a white gelatinous precipitate will be formed. It is zinc hydroxide. If excess aqueous ammonia solution is added, the white precipitate will dissolve. Colorless and water-soluble tetraamine zinc ion is formed. Ammonium ion. If a strong base, such as sodium hydroxide solution, is added to a solution containing ammonium ion, and the mixture is heated, a colorless gas will be produced. The gas is ammonia. It turns moist red litmus paper into blue color.
Okay, that is for your test for cation. Now let us try to look into uh, qualitative tests for anions.
Qualitative analysis of anions. This video clip demonstrates how to identify common anions. To analyze what anion is in the sample, we can add the appropriate reagents and observe the chemical changes. The following parts demonstrate the testing methods for common anions and the expected observations. Chloride ion. Halide ions can be identified by silver nitrate solution. Add silver nitrate solution to a solution containing chloride ion. A white precipitate is formed. The white precipitate is silver chloride. It is insoluble in water. If excess aqueous ammonia solution is added to the precipitate, the white precipitate will dissolve, and a colorless solution will be obtained. Silver chloride reacts with ammonia to produce water-soluble diamine silver ion. In addition, if the precipitate is exposed to sunlight, it will turn gray in color quickly. Bromide ion. Add silver nitrate solution to a solution containing bromide ion. A pale cream precipitate is formed. The pale cream precipitate is silver bromide. It is water insoluble. If excess aqueous ammonia solution is added to the precipitate will dissolve slightly. If the precipitate is exposed to sunlight, it will turn gray in color slowly. Iodide ion. Add silver nitrate solution to a solution containing iodide ion. A pale yellow precipitate is formed. The pale yellow precipitate is silver iodide. It is water insoluble. If excess aqueous ammonia solution is added to the precipitate will not dissolve. If the precipitate is exposed to sunlight, it will not change in color. In addition, halide ions can also be identified by chlorine water and organic solvents. Add chlorine water to the sample solution, followed by an organic solvent. Shake the sample and observe the change. If the anion in the sample is chloride ion, there will be no observable change. If the ion in the sample is bromide ion, the organic layer will change to orange in color. It is because the bromide ion is oxidized to bromine by the chlorine water. Bromine dissolves in organic solvent to form an orange solution. If the ion in the sample is iodide ion, the organic layer will change to purple in color. It is because the iodide ion is oxidized to iodine by chlorine water. Iodine is dissolved in organic solvent to form a purple solution. Carbonate ion. Carbonate ion can be identified by adding an acid, such as dilute hydrochloric acid or dilute nitric acid, to the sample solution. If the sample contains carbonate ion, a colorless gas will be produced. It is carbon dioxide. If the gas is allowed to pass into lime water, the lime water will turn milky by the carbon dioxide. Hypochlorite ion. Hypochlorite ion is alkaline and has bleaching power. Hence, it can be tested by red litmus paper. Stain a piece of red litmus paper with a solution of hypochlorite ion. The litmus paper turns blue and is then bleached to white. Sulfite ion. Sulfite ion has reducing power. It reacts with strong oxidizing agents. For example, if acidified potassium dichromate solution is added to a solution containing sulfate ion, the potassium dichromate is reduced and turns from orange to green. Similarly, sulfite ion can also reduce potassium permanganate. It changes acidified potassium permanganate solution from purple to colorless. Sulfite ion also reacts with bromine water and changes brown bromine water to colorless.
Identification of ions and cations or sorry, anions could be done through a series of tests, and this could be subdivided into two. You have the preliminary test and the confirmatory. confirmatory test. In the preliminary test, this is usually uh, done in order to determine the presence of the substance or not, or if the group as per the periodic table or in reference to the grouping in the periodic table, the preliminary test could be taken as a group test for the presence of such element. And then in the confirmatory test, this is more of an individual test for the presence of a cation or an anion. So, for example, a water solution of salt, sodium chloride. The anion or the acid radical is chlorine coming from the hydrochloric acid. So you could, from here, you could test already the presence of an ion chlorine. And also likewise, from the test of sodium chloride or analysis of sodium chloride, you could also test for the presence of sodium. So it depends upon what is the unknown that you want to determine. If you are trying to look for how high is the sodium content of the food, then you are trying to test for the presence of sodium and then later on quantify for the presence of sodium. Because aside from sodium chloride, there are still some other sources of sodium, like for example the monosodium glutamate or your betchin. So an ion is an ion with more electrons than protons. So in most cases, we are both looking for negative and positively charged anion. But there are different tests for the presence of anions. So in this case, you could look for the presence of chlorine. And the presence of the chlorine is equated to the presence of the positively charged sodium or the other way around. Now, how do we prepare test solutions? The test solutions could be prepared either as water extract or soda extract. If the unknown is soluble in water, we make use of what we call water extract. But if it is insoluble in water, we make use of the soda extract or the sodium carbonate extract. Water extract is easy to prepare. You just simply get 1 ml or 1 gram of the mixture or the unknown, and then you dissolve to 10 to 20 ml. Now for the case water, distilled water, always use distilled water in the analytical laboratory. Sodium carbonate extract, make use of 1 gram or 1 ml. It depends upon sorry, the nature of the unknown. And then this is mixed with 15 to 20 ml of distilled water. And then the difference is it is heated for 15 minutes. So it is longer as compared with the water extract preparation. And then after heating, the solution is filtered and the filtrate is now what we call the soda extract. So that is now the equivalent of the water extract. Now, why it is called soda extract? Because of the presence of sodium carbonate. And the soda that you drink usually have sodium carbonate. And then there are different classifications of anions. You are now in the negatively charged ions. And there are major classification. It depends upon how sulfuric acid is added. Now, dilute sulfuric acid group together carbon CO negative 2 acetate, sulfate, nitrate. and sulfide. Whereas for sulfuric acid, you have the most of which are the halides, the nitrates, and then the independent radicals. There are so many of these. And then let us try to look into how these tests are being done. So for the test of carbonate, you have here two approaches. The first one is, of course, the addition of water or soda extract, and then lithium nitrate solution and potassium iodide solution were added because more or less these are the unknown. After this, few samples of dilute ammonia is added and the resultant solution is heated. Again, uh, take note of some terminologies here. If in this case heated, it could mean direct heat or it could mean in a water bath. Usually the direction will say low heat, it means you are going to heat it using the double boiler. If the liquid from this turns into blue, it is confirmed that carbonate is present. Now, another test could be done by uh, adding equal volume of soda water extract and pure hydroxide in a test tube, and then it is heat, and it could evolve a certain odor, a distinct odor or hydrazine odor. And then if yellow precipitate is observed, then you are sure that uh, carbonate is present. Now, there are prepared test kits for some unknown or some ions, like for the case of nitrite. Usually, nitrite determination is done to determine the quality of water, especially for wastewater coming from industries, whereby nitrate is very high, thus causing the biological oxygen demand of the nearby river. So, in order to determine whether that manufacturing firm introducing wastewater to the river is polluting the river or not, a test kit for the test of nitrate is already available. So what we do in the lab, that is test tube by test tube, drop by drop, could be simply done using this test kit. So for the pretest, sulfuric acid is added. And then if a reddish brown vapor is produced, then you can say that maybe nitrite is present. Now, to confirm whether it is nitrite or not, from here, the solution is added with Kr or potassium iodide and followed by 0.5 ml of pure starch solution. If a deep blue coloration is observed, just like this, you can say that nitrite is present. And then another way is to get another new water extract or soda extract of the compound. And if you're going to add sulfuric acid and then followed by freshly prepared ferrous sulfate, a dark brown or black coloration is obtained, then you could say that nitrate again is present, just like in that sample. In field analysis class, wherein we do not bring any more test tube, these are actually vials that could substitute the role of the test tube. And in fact, these are prepared containers for sampling because there are already some graduation level here to say whether the sample contains 2 ml, 5 ml. These are calibrated. Usually, these vials here are calibrated. So we have also another test for acetate. This is more popular for the test of the presence of vinegar. So a piece of the mixture is treated with sulfuric acid, or if the mixture is taken in a watch glass, you just simply add oxalic acid and a few drops of water were added. If the experiment will exude a vinegar-like smell, then maybe acetate is present. But how to confirm this? The addition of dilute acetic acid followed by addition of ferric chloride will form deep red precipitate. Then it confirms that acetate is present. And then we have also tests for still for acetate, but in this case, it is through the addition of potassium iodide and a few drops of ammonia solution. A blue color is obtained, confirm that acetate is present. Or another, pure calcium hydroxide is taken in a test tube together with the extract or the unknown, and when this is heated, vapors will be produced and a yellow precipitate will be produced. So that will show that acetate is present. And then we have here test Paul sulfide. Uh, Upon the addition of sulfuric acid, if a colorless gas evolved and smells like a rotten egg, then you can think that sulfide is present. A confirmatory test could mean the addition of cadmium acetate will lead to the formation of yellow precipitate. Another way is the if you're going to boil the mixture of the unknown plus dilute acetic acid and expel carbon dioxide or a certain distinct smell, and then upon the addition of lead acetate, it will form a black precipitate, then sulfur is present. Or if you're going to add sodium nitroprusside solution to a soda or water extract or to the prepared unknown and violet coloration is obtained, then sulfur is present. This is how black is the sulfide upon the addition of sulfuric acid. And then the test for sulfide. Last time we are talking about test for sulfide. Now we are talking about test for sulfate. So upon the addition of sulfuric acid, if a smelly odor, colorless, odorous gas evolved, then you can think that sulfide is also present. But with the prepared extract, upon the addition of sulfuric acid and potassium dichromate, will produce green color, then sulfide is present. Or if uh, you're going to pass the gas with lime water and white precipitate is obtained, then sulfide is also present. For the test of chloride, which is a halide, there are different series, and this test is really very colorful. So upon the addition of concentrated sulfuric acid, a greenish yellow gas, but it is pungent in smell, will make you think that chlorine is present. Or if you're going to dip a glass rod ammonium hydroxide near the mouth of the above test tube, and the greenish gas will evolve, then you can also say that chlorine is present. Confirmatory test is the addition of silver nitrate. If you remember our first slide, the formation of white precipitate claims that it contains chlorine, or it could contain silver, or it could contain sodium. So we have also the famous chromyl chloride test for chlorine. A yellow precipitate is formed. So this is a series of tests or addition of chemicals to confirm whether chlorine is present. Test for bromine, another halide. So upon the addition of sulfuric acid, a reddish brown vapor, from here will be produced. Actually, in the laboratory, we no longer allow you to perform this kind of test because bromine is one of the considered hazardous substance, and hazardous substance for student laboratory activities is now prohibited. However, if you're going to add silver nitrate to a bromine, it will lead to the formation of a yellow precipitate or a dark yellow precipitate. Then, in some cases, bromine is also used in the determination whether the substance is an alkene or an alkyne. So, if it is an alkane, remember your organic chem, when you have done this, uh, a yellow color is produced. But if when you have done this in your experiment in the test for alkene, the absence of the color uh, brown or dark yellow is absent. So if there is no double band or triple band, the color of the organic compound is yellow or dark yellow. And here is the test for iodide. The test for iodide will tell you that upon the addition of sulfuric acid, violet vapors of iodine evolve from the test tube. But that is only preliminary. That is just simply thinking whether it is positive or negative. But what makes you confirm is upon the addition of silver nitrate, a yellow precipitate obtained will make you confirm that uh, iodide is present. Or upon the addition of nitric acid or chlorine water, and then this is warm the mixture. You're going after warming the mixture, and the addition of carbon tetrachloride will lead to the formation of violet color. So the sample added with carbon tetrachloride when heated gently will confirm whether that substance is positive or negative with uh, iodine or iodine. Rather. So next we have the test for nitrate. Again, sulfuric acid is added, light brown is produced. And for the confirmatory test, after the addition of sulfuric acid, you could add ferrous sulfate, and then more sulfuric acid, uh, brown black ring is produced between two layers will confirm that nitrate is present. And then for test of oxalate, uh, after the addition of sulfuric acid, and then if you're going to subject this with a flame test and a blue flame is produced, then you can think whether that substance is positive with oxalate or not. But to confirm the test, uh, after acidifying the extract, whether the soda or water extract of the mixture or unknown, with dilute acetic acid and then boil the solution and then add calcium chloride. If the test tube will eventually form a white precipitate, you could say that uh, oxalate might be present. Then, if you are going to add potassium permanganate and a pink color is present, calcium oxalate or oxalate is present. And if ferrous sulfate is added and yellow precipitate is produced, then the reaction confirms that oxalate is present. Potassium permanganate is dark violet in color. So upon the addition to oxalate, it could lead to the pink color. That is its reaction. You know very much that ferrous sulfate is dark yellow in color. So if it turns yellow, if it give or yield the yellow precipitate, then you are sure to say that oxalate also is present. And then we have here test for fluoride. When added with sulfuric acid, an oily droplet, a sort of an oily in nature, is formed at the sides of the test tube. Then if you're going to heat this and place a glass rod moistened at the top of the test tube that you are using, and a white gelatinous deposit is produced or seems like adhered to the glass rod, then fluoride is present. Actually, that is a hydrofluorosilicylic acid that was produced. And then for test of sulfate, upon the addition of sulfuric acid and the addition of barium chloride will give white precipitate. And then for test of sulfate, upon the addition of nitric acid, take note, nitric acid is added here. In the case of sulfate, it is hydrochloric acid, whereas the others, it is sulfuric acid. And then if ammonium molybdate solution is added and then boiled, then the yellow precipitate is formed. And that test will confirm that phosphate is present. And then you have here test for borate. In a porcelain dish, you add zero point 0.3 to zero point 0.2 grams and add nearly an ml of sulfuric acid followed by 1 ml of ethyl alcohol. And then when the porcelain dish is heated with a burning paper over it, meaning to say you're going to place the burning paper into the porcelain dish or evaporating dish. If a green flame is produced, then you are sure that confirms for its present. Then our next topic is actually cat ion, and that will be already for next meeting. However, I would like you to give some uh, preliminary discussion as to the scheme on the qualitative analysis of the 21 common cat ions. So this is by grouping. So for group 1, upon the addition of hydrochloric acid, a white precipitate will form. And then for group 2, upon the addition of hydrogen sulfide, then this will be produced of different result. It depends upon what element is present. Now, For copper, an orange or dark yellow precipitate or a brick orange precipitate is produced. But for bismuth, you have here the reddish precipitate that is formed. Now, the first thing that is to be done in the lab or in your analysis is to separate the group 1 ions from the rest. So these are your group 1 ions to be tested for qualitative analysis. So the precipitate that were formed could contain silver chloride that is white, mercury chloride that is orange, or the lead that you have seen in the previous slide. So if you're going to hit this group of uh, mixture, if these are placed in one solution, and if you're going to hit this, and when you add chromate and the yellow precipitate is formed, then lead is present. But if you are going to continue the solution to test for the presence of silver or mercury upon the addition of ammonia, then addition of acid, the formation of white precipitate will say that silver is present. Upon the addition of ammonia and a black precipitate was formed, then mercury is present. So how to determine whether your unknown is silver, mercury, or lead is to follow this schematic diagram. Chromate will give the yellow, acid will give the white precipitate, and just simply the ammonia will lead you to confirm that presume that mercury is present. So these are illustrations of the uh, chemical equation showing to you the formation of the different precipitate or the reactions. All the rest of the slides are telling you what happened in the chemical reaction. So I will leave this to you for your own uh, analysis or for you practice to determine what is the precipitate present. Now here is for group 2. So there are some that are similar with one another. There are also even some elements that differs in test, like for example aluminum. So the first that was tested here for illustration are your nickel, calcium, and according to this, most metal carbonates are insoluble. Of course, except for potassium, sodium, and ammonia. So when you're going to make some tests, uh, you can see here what precipitate or what are responsible for the color of the different tests. Like for example, for flame tests, these are usually used for uh, elements like lithium, sodium, potassium, rubidium, all the salts stated here. And it says here that ammonium is also soluble cation but yield no useful result in the flame test. It, it is identified from its property volatility and basicity. But for the case of others, you could use flame test. This blue, dark blue, there shows the presence of potassium. Here in this case, sodium. You will meet a lot of those. And then we have also precipitate formation to distinguish uh, different cations in this group. So you have here the test and you have there the result. White precipitate for sodium hydroxide, white precipitate again for sodium hydroxide, gelatinous white precipitate that is nearly colorless in nature, but you could see the difference, of course, from the original sample of the zinc. And then calcium will also yield white precipitate with sodium hydroxide. Now, for the case of its reaction to ammonia, you have here white precipitate if uh, aluminum is present, and then white precipitate also for lead. But in this case, white precipitate is immediately formed, but upon the addition of excess, it will yield to colorless solution. For the case of copper iron, ferrous and ferric, these are both iron, no? But uh, when added with sodium hydroxide, the ferrous yielded the dark green precipitate, whereas for the ferric, it yields the orange or dark yellow in color. Copper is both blue in sodium hydroxide and ammonia. However, in this case, in ammonia, uh, in a small volume, it yield white, light, milky white, blue precipitate. But in the upon addition of excess, it had produced a dark blue precipitate. Uh, Iron yielded green, this as the same, and also for both ferrous and ferric, they gave the same result to ammonia. These are the sub-physical appearances of elements that are tested for flame tests. These are Watts glass, and these are also special burner to test for flame tests. And then this is just a preview on your test for simple inorganic salts. So test for gases, ammonia, like ammonia, carbon dioxide, chlorine, hydrogen, oxygen, sulfur dioxide. So for ammonia, it will yield a blue color with red litmus paper. So these are just simple examples of different tests. Um, so I think that is all for today. Everybody is now uh, hungry and wants to go home. Okay, thank you again. See you in our next meeting. But expect already for a quiz next meeting. Okay, that's all for today.